Bismillahirrahmanirrahim. Chapter 10, Angles in a Circle, Exercise 10g. What is our main objective? To understand angles standing on the same arc of a circle and in the same segment are equal. So clearly you can see here in this picture we have this arc, right, a minor arc, and there's a chord over here drawn. So this chord is dividing the circle into two segments. This is the major segment and this is the minor segment. Now any angle that will be standing on this arc, for example, if you look at this angle, this is like this angle is standing actually on this minor arc, the one that I have drawn with the, let me show you with this black color. Okay, so this angle is standing on this arc, or you can say this angle is subtended by this arc. For example, let's say this angle is 40 degrees. Now if I will make another angle on the same arc and it's in the same segment, like it's going in the major segment, it's drawn in the major segment, so that angle will also be 40 degrees. So it means as many angles as you draw over here, if they are in the same segment and they are standing on the same arc, they are subtended by the same arc, all those angles will be of the same measurement. Clear? Okay, let me show you here more examples. Here it says angle standing on the same arc. So angle standing on the same arc of a circle. And remember, this word is also very important, in the same segment. So clearly you can see here we have this arc and all these three angles. Let me draw them with three different colors. So this is the first one. Okay, it's standing on this green arc, right? If I make the other one with the blue, so you can see again this is standing on the green arc. And the third one, it's also standing on the same arc. So all these three angles, they have the same measurement. Let's say how much it will be. For example, if this one is alpha, the second one will be alpha and the third one will be alpha. Because what is the reason why all of them are the same? Because they are subtended by the same arc and they are lying on the same segment. Clear? Okay, for example, if this angle alpha is, let's say, 30 degrees, then each angle will be 30 degrees. And this rule, or you can say this fact, it helps us a lot while solving the questions. Now here, as you can see from this picture, this is the arc actually. This red one that I am drawing right now, this is the arc. It's a minor arc, and all these three angles they are drawn with different colors. One is drawn with the red, the other one is drawn with the blue, and the third one is drawn with the green. So all these three angles are actually standing on this arc, or this arc subtends these three angles, and they are in the same segment. How I will know the same segment? If I draw a chord over here, so clearly I can see all these three angles are in the major segment of this circle. Clear? Now how I will find the value of angle E and how I will find the angle value of angle F? Now I will see that all of them are in the same segment and all of them are standing on the same arc. So this shows that E, F and 38, they will be equal to each other. So I can say the value of angle A is 38 degrees. The value of angle F is also 38 degrees. Clear? Now here is another example. Look at this one. For example, if I have this red arc, there are two angles that are standing on this arc. If I show you with the, for example, here with this blue color, look at this one. This is one of the angle that is standing on this arc, and then we have another angle, green one. It's also standing on the same arc. So the value of one of the angle is 40, the other one will also be 40. Now what happens if the angles are standing on a major arc? Here in all these three examples, the angles were standing on the minor arcs, means the smaller arcs. What if I have a major arc, right? Look at this. This is the major arc and there are two angles standing on it. Let me show you here. This is the first one. This is the first one, right? Its value is 100 degrees. And this is the second one where my pen is right now moving. This will also be 100 degrees. Let me show you live explanation of this idea. Just wait 1 minute. Here is the explanation. clearly you can see here, if I think about that, what is the rule or what is the fact that we are discussing, angles subtended by the same arc on a circle are equal in size. So let me show you the, for example, this is the arc, right? Now how I can draw the angles on this arc, let me show you. For example, one of the angle, now look at this is the angle, right? Even if I will move it over here, let me show you what is the value of this angle. Okay, what is the measure of this angle? It's 56 degrees. Let me make it, let's say for you, okay, I'm trying to make it a whole number. Wait, okay, it's showing almost like 44.99. that means it's 45 degrees. Okay, now if I move this angle anywhere in this segment, the major segment, it does not change, right? It remains 45 degrees. Now for example, if I make another one, another angle over here, it's standing on the same arc, it's subtended by the same arc. Look at this, it's also 45 degrees and it does not change, right? Now for example, if I change the size of this arc now, let's say I want to make it smaller, I want to make it more like it's a minor arc. Now look at this. Now the angle, its value is 21.62 degrees. Wherever I'm taking it, it's not changing, it's the same angle, right? So remember, because both these angles are standing on the same arc, so their measurements are equal to each other. Okay, so this shows that if the angle is standing on a minor arc, it's always an acute angle, and if the angle is standing on a major arc, it is always an obtuse angle. So we can make a rule that the angles that will be standing on the minor arc, they will be acute angles, and if the angle will be standing on a major arc like this one, so it will be always an obtuse angle. Clear? Let's start the questions from the exercise now. The questions are very easy. For example, here they are saying find the angles denoted by the letters. So here they want us to find the value of this angle H. So first of all, I will see this angle H. Where does it stand, or which arc subtends this angle? So clearly this angle is subtended by this arc. This is the arc, like, so I can see that this arc is a minor arc, and if I just draw a dotted line over here to see the segment, so this is the minor segment and this one is the major segment, and the angle green one, it's in the major segment. And the other angle that is drawn here, let me show you here, this one, it's also in the same segment. So when I say it's in the same segment, it's standing on the same arc, that means their values will be exactly the same. So I can say H equals 38 degrees. Clear? So both of them will be equal. Now here in this question, I can see here one of the angle is 39, and in the same segment I have another angle, it's I, and both these angles are standing actually on this arc. Okay, they are standing actually on this arc, right? Both these angles, clearly you can see here, it's going on this way and the other one is going this way. So this shows that both these angles will be equal to each other. So we can say angle I, its measurement will be equal to 39 degrees. Now if I erase everything from here and I think about J now, so look at this, J angle is here, it's in this segment, right? And angle 46 is also in this segment. So both these angles, J and 46, are on the same side, you can say, or in the same segment. And if I draw a dotted line, a dotted chord over here, so clearly I can see both J and 46 are in the same segment, and this is the arc on which they are standing, so that's why they will be equal to each other. So I can say J is equal to 46 degrees. Clear? Okay, let's solve some more questions from the exercise. These are very easy questions. Better pause the video here and solve both of them on your own. So here is the answer for both questions. All these three angles are in the same segment of the circle. That's why their values will be exactly the same. They will be equal to each other. So x will be equal to 33 and y will also be 33. Here L and 100, both of them are standing on this major arc. That's why we have an obtuse angle, they will be equal to each other because they are on the same in the same segment. Look at this, they are on the same side of the circle, right? So they will be equal to each other and their value will be 100 degrees. Here is another question. Better pause the video here, get the answer, and then play the video to check your answers. So we have angle W equals to angle 57. W and 57 are equal to each other because they are on the same segment of the circle, right? And if I look at X and this 123, these angles, both of them are on the same segment. Like these two are in the minor segment actually, right? And all this side is in the major segment, right? If I will do it like this, where the green color, you won't be able to see it, so I will erase this one. So this shows that all this side is in the major segment and this side is in the minor segment. These angles are in the minor segment, so they will be equal to each other, and so that's why W equals 57 and X equals 123. Okay, I have some challenge questions here for you. Better pause the video here. Now here, not only one idea, but some of the ideas that you covered in exercise 10A, they will also be used here. So better pause the video here and get the answer of both these challenge questions and then play the video to check your answers. So here are the answers for both questions. Here B option is correct, and here in this question B option is correct. Now actually, you know what you have to see is we are trying to find this angle E, and I can see in this triangle I have one of the angle 92 and I want to find E. How much will be the third angle? So this third angle I can find with the help of the rule that the angles subtended by the same arc are equal to each other. So if this angle is 57, for sure this angle D will also be 57 because both these angles are standing on this arc AC. Clear? Okay, if I know this is 57, so the rest of the steps are very easy. How do we find the third angle in any triangle? We subtract the sum of these two, 92 and 57. Its sum will be subtracted from 180 to know the value of angle E. So it will become 31. By the way, and they can ask you the same question in a little bit different way. Maybe they can ask you how much is the value of angle X. Like it seems it's a very complicated picture and how we will know the value of X, but it's very simple. Why? Because we can see here that we have vertical angles over here. These two lines are crossing each other, or you can say they are making an X shape. So if this angle is 92, so this angle X will also be 92. Clear? Okay, now this question, the second challenge question, they want us to find the value of this angle B. Like how much is this one? Again, I will look at the triangle, how many angles I can measure, or I can think that how many angles already their measurement has been given. So this angle is 85, and how can I find this angle C? Because C and this angle D are on in the same segment of the circle, and both of them are standing on this arc AB. Clear? So for sure this angle will be 32. Now I will add 85 and 32 and subtract it from 180 to get the third angle of the triangle. So it will be 63. So B option is the correct option. That's all for this exercise. Hope you understand it.